Hello, and welcome to a digital lecture for Salt Lake Community College. This lecture will be the fifth to cover section 4.1 for Intro to Statistics, considering examining quantitative data. This video will specifically cover some of the measures of center and variability discussed up to this point and how resistant they are. When we say that something is resistant, we imply that extreme observations, such as outliers, have little effect on their value. Some statistical measures we've discussed in previous sections can be very influenced by these extreme values due simply to how they are calculated. Overall, for symmetric distributions, use the mean as the measure of center and the standard deviation as the measure of variability. For skewed distributions, where extreme values can be an important factor, use the median as the measure of center and the IQR as the measure of variability. Because the median and the IQR do not use or depend on all values in the dataset to calculate, specifically extreme values, we say that they are more resistant than values like the mean and the standard deviation, both of which require the value of every observation in our dataset, including extreme values. Range is another measure of the variability in the data, computed as the maximum value minus the minimum value. It is rather simple to find, but it is not resistant at all, as the maximum and the minimum values can be, and often are, extremely different than the majority of the dataset. As a summary, we have a few measures that are resistant. We have the median, the mode, and the IQR are resistant measures, the median and the mode being measures of center, and the IQR being a measure of variability. As for non-resistant measures of center and variability, we have the mean as the measure of center, and the variance, standard deviation, and range as measures of variability. All of these four values for non-resistant measures rely on and depend on every value in the dataset to calculate, including any extreme values. The shape of the data can have a few implications on the value of the mean and the median, and vice versa. If we compare just the mean and the median, we can often also get an idea of the shape of the distribution. If we look here, we have a symmetric data set. When we have a symmetric data set, what that tends to imply about the mean and the median is that they are approximately equal to each other. I will not say that they are exactly equal to each other because you should not expect two values to be 100% the exact same. We often will have small amounts of variability, but if they are rather close, we have an expectation of symmetric data. We do have symmetric data that indicates that the mean is the best measure of center and the standard deviation is the best measure of variability. For skewed data, both left skewed and right skewed, we have, in this case, the mean and the median are not going to be the same value. The extreme values in these cases tend to be in what we call the tails of the dataset. So we tend to indicate that for left skewed data, we have extreme values on the left side, and for right skewed data, we have extreme values on the right side. Extreme values are very important in terms of calculating and determining how different the mean deviates from the median. Specifically, the mean tends to be pulled in the direction of these extreme values. So, for left skewed data, when we have extreme values on the left side, we would indicate that the mean is pulled in that direction, whereas the median tends to be pretty close to the peak of this curve. Therefore, because the mean is pulled to the left, we would indicate that the mean tends to be less than the median in these instances. For left skewed data then, because it is not symmetric, we would then use non-resistant measures such as the median and IQR to measure center and variability. On the flip side, for right skewed data, we have extreme values far on the right that are pulling the mean up to be larger. So we indicate that the mean is larger than or greater than the median. And just like with left skewed data, the median and IQR are still appropriate measures of center and variability. The example on the next page will look at a small data set, as well as its GeoGebra output. We have here hours working. A random sample of 10 college students were asked, how many hours per week do you typically work outside the home? The responses are as follows. We have values 0, 5, 18, 20, 24, 28, 30, 30, 35, and 40. This data was already put into GeoGebra, and we have the output below. We have the statistics here, including the sample size, the mean, the standard deviation for the population, if it was a sample, the sum of the values squared, and the 5-number summary. We also have that 5-number summary translated into a box plot. And we see, based on this box plot, a specific shape that seems to emerge. We have the median represented here as the middle line in the box plot, and then we see that the box plot tends to spread more towards the left side rather than the right side. This indicates to us that this distribution is likely skewed to the left. Because it is skewed to the left, we can answer the next question appropriately. We see, is the mean or the median a better measure of center for this data, and why? Well, because we have the idea that it is skewed to the left, we would believe that the median as well as the IQR are better measures of center and spread. My answer here is that the median is a more appropriate measure of center based on the provided box plots because this data seems to be skewed left. Now, if we look beyond just the shape of the plot and look at the actual values of both the mean and the median, both of those are presented here. We have the mean is calculated to be 23 in our GeoGebra output, and we have the median calculated to be 26 in the GeoGebra output. Because we have a skewed left distribution, we did expect the mean to be less than the median, as demonstrated in the example prior. So, for the answer for this question of do the values for the mean and the median compare to each other as you would expect based on the shape of the box plots, our answer is yes, the mean is 23 and the median is 26 based on the GeoGebra output, which does match what we would expect because the mean is less than the median, which is expected for left skew distributions. If you have any further questions, be sure to review the example videos or ask your instructor.